right, today we're going to talk about different angles that are related in a circle, looking at the measures of central angles, which we've already talked about, inscribed angles we've already talked about, but then the connection to tangent chord angles, and then when you use tangent, secant, and chord segments, the other angles that you are looking at. First one is going to be related to the central angle. So we're looking at a group of, and the only angle, but it's the angles where the vertex is at the center. So the vertex of the angle that we're creating is at the center. The two segments that create it are the radii, and that is where the angle is always equal to the intercepted arc. So those radii intercept the arc at A and B. That arc is 80 degrees. So the angle is equal to 80 degrees. Next group of angles we're going to talk about are the groups of angles where the vertex is on the circle. So the first one we've done is the inscribed angle, where the vertex is on the circle and it intercepts the arc at A and C, and that arc has a value of 100. Therefore, the angle must equal 50 because it is half of the intercepted arc. Another angle that we would have with a vertex on the circle is called a tangent chord. So we have a tangent segment where it's only touching the circle at that one spot. And then the chord, the arc that it intercepts is here, in this case, an arc of 120 degrees, and half of that would be 60. So anytime we're looking at a vertex that is on the circle, we're talking about an angle that is equal to half of its arc. Next angle are angles where the vertex is inside the circle, but also it's not the center. And when you get an angle like that, we are talking about a chord. So two chords are drawn inside a circle, and they create an angle. Now there are multiple angles here, so if I want to look at X, I really could be talking about X, or its vertical angle is also X. They're the same thing. But it intercepts two separate arcs here. We go B to D and C to A. There are two intercepted arcs that go with angle X, and in order to find the angle, there we're doing half of the sum of those arcs. So it adds 70 and 170, and then divide that by 2. The next one are three different angles where the vertex is on the outside of the circle. So the first one we can do is created by a tangent and a tangent. Tangent segment, and intercepts with an arc of 260, and then inside there an arc of 100. For the next one, we have two secant segments, and it intercepts the circle in between those two segments with an arc of 80 and an arc of 20. And then in the last one, we have a tangent and a secant, and it intercepts the arcs in between those with an arc of 100 and then an arc of 30. And for all three of these, where the vertex is on the outside, we're going to do half the difference of the arcs. So then applying these, C is the center of all of these circles. So in the first one here with C as the center, that is a central angle. So that would mean that AB is equal to the same thing, which is 54. BD is the rest of it, and the diameter then cutting it in half, so 126 degrees. Same concept in number 2 with C being the center. Supplementary is 105. So GE is 75 and EF is 105. And this is all because central angle is equal to its intercepted arc. In number 3, I know that angle 1 has to be 120 because it is a central angle equal to that arc. For angle 2, I need to remember that this is an isosceles triangle because they are both radii, which means those opposite angles would be congruent, which means they each need to be 30 degrees. For number 4, we have some inscribed angles. First off, I have a triangle, so I can find the missing angle in the triangle is 78, subtracting them all from 180. When I look at 57 degrees, it corresponds to arc JK, because that's where the two segments, the chords, intercept the circle. Twice 57 would give me the arc JK. So 57 times 2 gives me 114. If I wanted to find arc IJ, that corresponds to the inscribed angle of 45. So that gives me 90. And then I could subtract those two from 360 to find the last one, or do the same process, but I would get 156 degrees. For number 5, parallel lines here. I have alternate interior angles, so that is a 43-degree angle. So 43 degrees is an inscribed angle, corresponds with the arc of MN, which is 86. I would get the same thing on the other side. And because LN is the diameter, then I know that ML needs to be 94 because the diameter cuts it in half. As you start to see, some of these problems are going to have multiple ways of doing them in times. In this case, we have a triangle. We have inscribed angles. We can look at a couple different things. But first off here, we have a vertical angle, so I know that across from 63 is 63. I then have a triangle on the right here, so I can subtract those angles from 180, leaving me with 70 for angle Q. And then as far for arc SR corresponds with the inscribed angle of 70. So I now know that arc SR is 140 degrees. For this one, we have a vertex that is on the outside of the circle, so we need to take our two arcs of 140 and 40. And we're going to do half of the difference of those two arcs. So half of 100 is 50 degrees. Same thing here with a tangent. If this arc here is 140, the other arc has to finish off to 360, so that is 220. Vertex is out on the outside, so again we do half of the difference, 220 minus 140. So we'll get 40 degrees. Number 9, again, vertex on the outside. Arc of 110, arc of x. So 40 is equal to half of the difference of 110 minus x. So when I solve it, I can multiply both sides by 2. I'll get 80 equals 110 minus x, and so I know my x value here is 30. A lot going on in number 10. First off, I'm going to look at the inscribed angle of 20, which corresponds to that arc. So I will make that arc 40 degrees. Next, I have an angle of 80, which corresponds to that arc, which makes that arc twice 80, which is 160. Then I have an angle that is on the outside of the circle. And so that angle is going to be half the difference of my arcs. Half of 160 minus 40. So x is going to equal 60. For number 11, inscribe an angle first for 28. 28 times 2 gives me 56. First off, I need to find the arc that goes on here on the outside. And that arc is related to that chord angle. So this vertex is on the inside of the circle. So that means that 60 is equal to the sum of the two arcs that correspond with it. The other arc that corresponds with it is 56. So 60 is equal to, let's call that y. Y plus 56 times a half. Half of the sum of the arcs, which will give me y is equal to 64. Then I can look at the angle that's on the outside, corresponds to the same arcs, except when the vertex is on the outside of the circle, we do half of the difference of the arcs. So x is going to be equal to half of 64 minus 56, which gives me x equals 4. There are 4 questions left, 12, 13, 14, and 15. Please finish those on your own.